Okay, so we are going to talk about effusion and diffusion today. So diffusion or diffusion is the process by which gas spreads through another gas to occupy a space uniformly. So many of you have probably heard of diffusers that are putting gas into the air, and then those gas molecules that are being diffused are evenly spreading out until they uniformly are occupying the space, whatever room you have that diffuser in. So there's no calculations for us to do with diffusion. There are some calculations that we can do when we're talking about effusion. So effusion is the process by which a gas flows through a small hole in a container. So an example to this would be like a pinprick in a balloon, where gas molecules are slowly effusing out of that balloon. So one thing that we can do with effusion, it's called Graham's law of effusion, is that we can calculate the rates of effusion. We can compare different gas molecules to each other. The rate of effusion, the formula for rate of effusion looks like this. Rate of effusion is 1 over the square root of the molar mass of that gas. So this is rate of effusion for gas molecules. So if you have the molar mass, you can determine the rate of effusion, but you really have to have something to compare it to. So the most of the time, the way you're going to see these problems reading is it's going to ask, there's going to be a mixture of two gases, and then it would say compare the rates of effusion of this gas to another gas. You really have to have a standard to compare it to. So let's look at an example. So this example says both hydrogen and helium have been used as the buoyant gas in blimps. If a small leak were to occur, which gas would effuse more rapidly and by what factor? Okay, so that's the whole question. So let's see how we can solve this from this question. So we are essentially comparing the rate of effusion of hydrogen to the rate of effusion of helium. Hydrogen and helium. Again, it's going to be really important that you remember the diatomic molecules. Hydrogen is a diatomic molecule. It's H2. So when you see hydrogen written here in this problem, you need to think H2. If you just write H, you will have the wrong molar mass and the problem will be wrong. Helium is not one of the diatomic molecules. It is He. So we're comparing the rate of hydrogen to the rate of helium. I'm going to compare the rate of hydrogen to the rate of helium. So I'm just going to see what are those rates of each of those. So I'm going to say up top, 1 over the square root of the molar mass of hydrogen. So 2 hydrogen, so it's going to be about 2.016 grams per mole, over the rate of helium, which is going to be about 1 over the square root of the molar mass of helium, which is 4.002 grams per mole. So you essentially are you're looking at comparing these two rates, you get a factor of about 1.4. What this means is hydrogen will effuse more quickly by a factor of 1.4. So that means hydrogen will effuse 1.4 times more quickly than helium. What is true is because the rate of effusion has to do with the molar mass, the smaller the molar mass, the quicker the gas will effuse. And that's what you need to know about effusion and diffusion.